Okay, so in this video we will look at the international standards, available international standards that you can use in the industry. Okay, the common one is IEEE. Okay, IEEE standards. So this is an example of an IEEE standards. So the standards is Ieee Std Standard 43-2013. Okay, so standard 43-2013. So 2013. This is the latest one. Before 2013, the previous version was 2000. So after 13 years, IEEE has revised this IEEE Standard 43. So what is IEEE Standard 43? IEEE Standard 43 is IEEE recommended practice for testing insulation resistance of electric machinery. Okay, so in this case, if you want to perform high voltage test, which is insulation resistance test on any electrical machine, motor or generator, you can refer to IEEE Standard 43 and use the latest one, which is test 2013. Okay, so basically you can get this in IEEE Explore. Okay, log in to UTHM library website, and then you can access the IEEE Explore. So you can get all the IEEE standards in the IEEE Explore for free, as long as you are a student. Okay, so this the standard, so many pages. Okay, one of the important part I want to show you is table 1 here. So this is taken from the IEEE Standard 43. Table 1, guidelines for direct voltages to be applied during insulation resistance test. So during IR test is high voltage test. So what is the voltage level that need to be applied to perform the IR test? So this is for machines, rotating machine, single phase, 3-phase, or AC machine, DC machine. So all machine will refer to the standard. And then if the machine or the motor, for example, rated at, let's say, motor is rated at 5 kV. Okay, the motor is rated as 5 kV. Then you need to use voltage value between 1000 to 2500. This is the voltage value that needs to be injected to the motor to perform the test, to perform the IR test. So the standard provide this kind of details so that you follow the standards. So everyone will follow the standard, so that no one, if you have 5 kV motor, you will not use 500 volt. You will not use too high voltage. 10 kV. You can follow the standard. If the motor is 5 kV, for example, you can use either 1000 to 2500. This is good enough to get the accurate results. Okay, because all the standards come from the investigation, from the research, from the experience. So the committee has gathered and discussed on what is the suitable voltage level to test on this machine. All right. So next, another example is IEEE standard. Look at here, C57.152-2013. Also the latest one, 2013. Previous version was 1995, right? So IEEE standard C57. Okay, before it was standard 43. Now it's standard C57.152. So this is for IEEE guide for diagnostic field testing. Okay, diagnostic field testing or in-service testing of fluid field power transformers, regulators and reactors. So take note on the term here, fluid field power transformers. So for dry type transformers, you have to use different standard. Okay, so this is specifically for diagnostic field testing, okay, to test on the transformer at site, and for transformer filled with oil, fluid field. Okay, so for example, what I want to show you here is figure A.3. This is taken from the standard. So this is how you do the connection to test on the transformer. Okay, so this is for you can use this to test on tan delta. Okay, this is tan delta test connection. Okay, this is taken from the standard. So follow the standard how to do the connection, right? And then besides IEEE, we have IEC. Okay, so IEEE is based in the US, IEC is based in Europe. Okay, usually IEC standard comes with two languages. Okay, first is English, second is French. Alright, so IEC is based in Europe. Okay, and Malaysia, we have Malaysian standard, MS, Malaysian standard, and Malaysian standard is usually based on the IEC standard. Okay, we usually just copy what the IEC standards are and copy adopted in Malaysian standard. Same thing for British standard. British standard also refer to IEC as well. Okay. So this is okay. The standard is IEC 60034-27-1. Okay. So this one, the standard for IEC standard, you need to either you can purchase it online, or you can go to CIRIM, from here CIRIM Technical Library, or you can purchase it from Malaysian standard. I cannot remember, is it Jabatan standard, I'm not sure, but the government has a local authority where you can purchase the standard through them. Okay, to get Malaysian standard or even IEC standard. Usually IEC standard is quite expensive. So in this case, IEC 60034-27-1, this is for rotating electrical machine, also electrical machine, motor or generator. So 60034, okay, is for rotating electrical machines. Okay, 60034 is the code for rotating electrical machine. -27 part 1 is for offline partial discharge measurement. Okay, so for tan delta test, you have to use different parts. So tan delta test, if I'm not mistaken, is IEC 60034-27-3. Okay, so for -1 is for offline partial discharge, -2 is for online partial discharge, so -3 is for tan delta test. So this actually, you can go to the IEC website and just key in the code. You will see that -1 is for offline PD, -2 is for online PD, for tan delta is -3, and several other tests is different dash. Alright, so that's the code of the standard. And then on the right side, this is an example of what is available in the standard. Okay, of course I cannot share you the standard because this is you have to purchase this, and we don't provide in UTHM the standard, but you can actually go to you have to personally request from the library for them to get the standard. Okay, just email to them, please help me get this standards, and they will try to find the standard. If it is available from them, they will share with you, otherwise you have to purchase it. Okay, so this is some information from the standard. Figure 5, test circuit for PD measurement. Okay, PD measurement on the motor, on the rotating machine. So we have 3 windings, UVW, or red, yellow, blue. How to perform the connection of the partial discharge? Just follow the standard. Okay, so which terminal needs to be grounded, which terminal needs to be connected to the coupling capacitor, to the matching impedance, to the PD measuring equipment, which terminals should be left open, floating. So just follow this, follow the standard. Alright, and then what is the how to apply the test voltage? You can apply it either in step voltage, alright, from 0 to 0.2 of rated voltage to 0.4 in step, or you can just in continuous ramp test voltage, and then reduce to 0 back again. So these are available in the standards. Okay, if you follow the standards, no one will argue with you. So besides IEEE, IEC, we also have SIGRE. Okay, SIGRE stands for International Council on Large Electric System, SIGRE. So SIGRE itself is not it's not the standard. How should I say? Basically, it says here it's a guide. Okay, it's a guide. But the industry also use this, consider this as standard. All right, as long as it is accepted by the international, then we can use it to apply in the industry. Okay, guide for transformer maintenance. Okay, the code is 445. Okay, SIGRE 445. Okay, that is for guide for transformer maintenance. Okay, and 445 is produced by working group A2-A2.34. So this is name of the working group that actually consists of experts from industries, from US, from UK, from Europe, from China, from all over the world. They attend this working group, discuss and produce this guideline for transformer maintenance in general. Okay, published February 2011. Okay, another example is this one. You have to go to SIGRE website. Alright, SIGRE websites. You can actually get free membership if you are a student. So just register with SIGRE, show that you are a student, proof of you are a student, and then you will get free membership. Once you get the free membership, you can actually download all the documents for free. Okay, even the standard. Okay, for example, this is taken from the standard 445, table 33. Okay, how to interpret the tan delta, let me see, capacitance and the electric power or dissipation factor. Okay, so this is if you perform the tan delta test, or you perform the dissipation, the electric dissipation factor test. This is just a different name of tan delta. So you perform the test, you can on the bushing of transformer. Okay, for measurements on winding, values are normally in the order of 0.5%. A measurement higher than 1% is questionable. For bushings, the following values are given in IEC and IEEE standards. So even the SIGRE also follow the IEEE standards sometimes, right? Not all the time, but they also produce their own values. But in this case, in this table we can see that if the bushing, okay, is resin impregnated paper, this is the type of bushing, and if the bushing is using oil impregnated paper, or if the bushing is using resin bonded paper, so the value of the tan delta, okay, the acceptable value of tan delta is different. Okay, typical new values is this. If using OIP, is this the value? If RBP, this is the value, and then IEC standard using this value, IEEE standard using this value. So basically, based on the C-grade value or IEEE or IC value, and then you can say that the system is acceptable or not. If the value is less than that, then it is good. If the tan delta value is above this value, then this is not good. Alright, just so our interpretation, okay, our interpretation is based on the international standard. Alright, so that when you perform the test, you explain this to the client, okay, to the asset owner, tell them that, okay, based on the standard, the value that we have tested is very high, is 1.1%, for example. Then according to the standard, this is above the acceptable value, so the equipment is not good. Alright, so this is going back to the previous, but never mind, we just go through this quickly. So in previous video we have looked at the two categories of tests, a destructive test and then the non-destructive test. So just quickly, the first one, destructive test, normally the equipment that undergo through destructive tests cannot be used in the service. Okay, let me try to read this again. Normally the equipment underwent destructive test cannot be used in the service. Okay, there's another meaning to it actually. Let's go to the second one first. Go or no go test. Okay, destructive test is also called go or no go test, meaning if the equipment fail the test, then the equipment cannot be used. Okay, so that it failed the test, we cannot use it anymore, we have to replace the equipment immediately. Okay, so meaning because the term go or no go test, if it's failed the test, it's a no go, means that you cannot use it anymore. It's failed, we have to replace. If it passed the test, you can go, you can continue use the equipment. So when you perform destructive test, you need proper planning. Okay, proper planning, meaning that you have to stand by replacement in case of fail. For example, you perform test on underground cable, underground medium voltage cable. You perform destructive test on the cable, and somehow the cable failed the test, the insulation has puncture, okay, problem, you cannot use it, you have to replace it immediately. So because of that, you always need to have proper planning. You always need to have a standby replacement unit. The cable fail, you have new cable to replace. Okay, so you need proper planning. And then usually destructive test, the test voltage is higher than the normal working voltage. Okay, for example, 2 times rated voltage, 2 pu of the rated voltage. Because why? We want to simulate line to ground fault. We want to simulate line to ground fault. That's why we inject voltage higher than the normal operating voltage. So if the cable can withstand line to ground fault, then meaning we are confident that after this, during operation, somehow there's a line to ground fault, and then the fault caused over voltage in the system. Cable can withstand, so no problem. Okay, circuit breaker will trip, and then no fault on the cable, no problem with the cable. So that's why we perform destructive tests. So for example, is breakdown test on solid insulation, high pot test on power cable. So these are all destructive tests. Okay, means that pass or fail test, go or no go test. If it pass, you can use it. If it fail, you have to replace it. Okay, so that is the meaning of destructive test. And the second one is non-destructive test. Okay, so non-destructive test is test that we perform that will not destroy the equipment. Okay, we perform, it is still high voltage test. We still apply high voltage supply to the equipment, but it will not damage the equipment. It will not damage the test object. Okay, because non-destructive test mainly used, okay, to assess or to evaluate the condition of the insulation. Okay, for example, insulation resistance test, IR test. Another example, dielectric dissipation factor test or tan delta test, partial discharge test. So this test usually will not go beyond the rated voltage. Okay, but usually rated voltage and below, because we want to assess, to check on the insulation properties. We want to check on the resistance. We want to check on the dissipation factor. All these the insulation properties of the equipment. All right. So the apparatus is not destroyed during the test and can be used again. The apparatus may be fail because of the test, but it still can be used again, but need to be replaced soon. Okay, what does I mean here is actually go back to here. Right, this is tan delta test or dissipation factor test. Okay, if the test give value, for example, 1%, okay, which is above than the recommended limit, the acceptance limit of the table. Okay, it failed the test. Okay, because the tan delta value is very high, but you still can operate this. Okay, but take note that it is not safe to continue using the equipment for a long time, because it will fail in near time. Okay, very soon it will fail. Okay, so it does fail during the test, means that the value is above the acceptable limit, but you still can use it, but be careful, because sooner or later it will fail. Okay, so the test apply voltage at rated or less than the rated voltage, and the test is conducted on material or apparatus without destroying their internal or external physical characteristic. Okay, it will not affect the material. Okay, it's just to measure the material properties. Okay, this test is used to ensure that the apparatus has not deteriorated after high voltage test, even though it has withstood the test successfully. Okay, let me finish this first. Test also provides the information of the quality of installation before it forms part of an equipment. Pre-durability test. Okay, example, IR test on cable before and after the high pot test. Okay, point number 2, 3 and 4 it's the same thing. Okay, basically what it says that this is an example. As an example, in the industry, we perform high-pot tests on cable. Okay, we perform high-pot tests on cable. So high-pot test is destructive test, right? Pass or fail test. But it is also common in the industry that we perform IR test, which is non-destructive test, the IR test, on the cable before and after the high-pot test. So IR test, high-pot test, and then IR test again. Okay, non-destructive, destructive, and non-destructive. Okay, and of course, if the reason is we want to compare the IR test value before and after the high-pot test, the cable may be past the high-pot test. It may be past the high-pot test, but we still have to look at the value of IR test before and after. Okay, if the IR value after the high-pot test is the same as before the test, before the high-pot test, means that the cable is okay, very good. If the IR test after the high-pot test is less than the IR test before the destructive test, that means that the cable, although the cable passed the test, but the IR value is now getting lower, very weak. Okay, maybe in long term it will not able to withstand. Alright, so that's the idea, pre and post. Okay, so in next video we'll look at the insulation resistance test.